Huh?
Like say
$1?
5 times the traffic.
No.
Might even get more. So
Okay, we live. There you go. We all good. Hey guys, how you doing?
Let me grab
Oh,
my
we got Miguel over here. There you go. What's up, buddy? I can hear you.
I mean, we just need to get some good hard line estimates from it.
All right. So, well, before we start, let me just remind that we have a Q&A session that you can guys use any question. After we finish, Alex is going to be talking today about workers and how we can use it with the payloads and do cool stuff with Node.js. So, hope you guys like it. And once again, we have a Q&A session. You can just ask any questions about what he's going to talk or whatever related with Node.js. And Alex, you tell me when you're ready.
Yeah, 1 second.
Okay. All right. I'm gonna make you present right now. There you go. So, give you a couple of minutes. For those who are online, I post 2 links. One on the community side for Google, with the link if you guys want to join to the session. Also, I posted on the CodeGym meetup site, so if you want to join, you can do it there too. What else? There you go. So we're just waiting a couple of minutes until Alex finish some technical issues.
We could experiment with making, we provision a big
and go live.
battle like LTO cloud server, and we.
Oh, there you go.
But we use the other big.
Now I see myself. There you go.
But because we're talking about
Can you see me?
Yes, we can see you and we can hear you. So
Second, let me pull this away.
It's all yours. The speaker presentation, everything's yours.
Do containerization? What?
Are you still in the office?
Yes, we're still in the office. We just finished another meeting.
Oh, okay.
Okay.
How you doing, Juan?
What's popping, bro?
Okay. I'm ready. You guys ready?
Yeah, I'm ready. Go for it.
So today we're going to talk about Node.js mainly, and about so-called manager and workers. As Angel described already, what we're going to talk about. And my name is Alexander Tashchuk. I'm all things programmer. I do Node. I do, backend, a little of the front end, mostly JavaScript. And if you want to hit me on my email or Twitter, just hit me and maybe we chat or go grab a beer or something. So, what's a manager and what's a worker? Maybe you do know, maybe you do not know, but we're not going to start with that. Before we start talking about manager and workers, we have to understand how Node.js process works. What kind of application you can build with Node.js, and what stays in the background of the Node.js. We have to ask a question if Node.js is multi-threaded or single-threaded application. And maybe a lot of you know, but that Node on itself, it's a single-threaded application. It's a single-threaded, like I said, uniprocess application, and that sucks. Because basically that gives you an idea that that's PHP, right? In a sense, yes, but not really. People say that it's asynchronous. And how is it asynchronous if it's uniprocessed? Well, yes, it is asynchronous, but to some point. It's asynchronous with input-output operations.
How to make it second link? You see the video web server? Yeah, we have.
Sorry.
Yes.
Can you hear me now? Okay. So as I said, it's asynchronous to only input-output operations. It's uniprocess if you want to process something on its main thread, saying that it will block the thread on itself. And maybe that's odd for now for you, but when we go through the examples, you'll understand. So this is how Node.js, the Node.js representation of how it works. As I said, Node.js handles asynchronously just non-blocking I/O processes. So in this picture, you can see that there are requests coming from the outside world, like HTTP requests, maybe RabbitMQ, and so on and so forth. Those requests get delegated to the main process of Node.js or your Node.js application, which runs in an so-called event loop. That process checks that request and says, oh, okay, that's an input-output operation. That request requires an input-output operation, which might be, a call to the database or to the file system on itself. So that main thread of Node application, what it does, it delegates that request to the so-called backend server of Node.js, called POSIX async threads pool. When it does so, it puts a callback into the event loop, saying that, oh, when the process reading from the database or from the file system is done, please notify me through the event loop by calling this callback function. So basically, when the reading from the database or writing to the database or to the file system finished, it notifies the event loop, and the event loop will say, listen, man, I am processing something else right now. I cannot respond to your callback because I get another request, what I'm looking at. During that time, if there's, like I said, a request, it would delegate back and saying, please wait and notify me a little bit later. So the POSIX will hit the event loop as long as multiple times until the main thread actually doesn't process anything and it's ready to get that event and process that event. So basically, that's the whole idea of Node.js. So when we work with application in Node.js, we're actually working with the main thread, with this little arrows. So at that point, the drawback in all of this is that if you want to process some long, heavy tasks, operations, which doesn't require input output, what the heck do you do? Because if you start, one example would be reading. There is a function in Node called fs read file sync, which means that I'm not going to put it into the POSIX async thread, but I'm going to read it directly from the main thread. In that case, it blocks the thread entirely, so no request or anything like that will come in, and the process will not be able to take those in and process them. So in this case, a new concept gets introduced of writing managers and workers. So in that case, the manager, what you do is a small function you write in your application, which gets treated as a POSIX async manager, which manages the workers, which are separate threads, separate forks of the main process. And we'll dive into that, and I'll show you examples of that. But before we do, I want to actually show it to you that the main thread can be blocked and cannot get any requests from the outside world until it executes that job. It executes. So let's see. So can you see it? Do I make it bigger? Maybe bigger. Good. So here we have a small application which just says that I'm going to print code gym in this case hello codegym, in 1 second. At the same time, the subsequent line says, I'm going to block the thread for 5 seconds. And blocking the threads is just a simulation, in this case, by running a while loop for 5 seconds. So what happens is when you put this job, like I should say hello in 1 second, into the event loop, and then you start blocking the thread, the event loop will go and ask the main process, listen man, can I give you this, print hello codegym? And the main process will say, hey, no, not yet, I'm still processing something else. And let's run this application and see how that happens. You see it blocking, it goes seconds, maybe I increase it. Run it again, just increase it some more. Blocks it, and blocks it, even though the codegym should have printed already, in a sense, after 1 second. And it prints it after 5 seconds, not after 1 second. There's another idea in NodeJS. People think there's this library called async. And a lot of people think, and I was the same at the beginning, thinking that, oh, there's this library async. That's probably, spawns separate threads, and I can run those functions or those processes in parallel. And I actually wrote a small application with the same idea behind as the previous example, just to disprove that, that people think that it's, non-blocking threading and all that stuff. And what I'm doing here, I'm calling the async library, which says I'm going to process the items you give me, the functions you give me, I'm going to process them in parallel. And whenever I finish processing them, I'm just going to call the function, the last function, notifying that I'm done with all of them. So basically what I'm doing here, I'm also delegating this functionality, the first and second one, to the event loop. And I'm saying, please call this within 1 second after I've been delegating that job to you. And the event loop essentially would call that in 1 second, but since I'm calling the I block the thread for 5 seconds after that, the event loop will call the main thread, and the main thread will say, I can't take it because I'm processing it. I'm processing the something is blocking my main thread. So let's see how that looks. Example.
Yeah,
Alex,
124 gigs of RAM.
Yes.
can you resize a little bit the window so we can see the whole thing, because it's too low.
Which
The terminal, like resize a little bit.
Oh, okay.
Like move it to the top. Yeah, there you go. There you go.
That's fine.
Yeah.
So I mean, I think you're just shuffling.
So I'm running the second application, which, as you guys saw, should run 2 functions in parallel, and they should execute within 1 second of delegation them to the event loop. At the same time, I'm blocking the main thread for 4 seconds. So essentially, what's going to happen? Those functions will get executed after 4 seconds, basically at the same time, with 1 or 2 millisecond delay between them. And let's see that happening. So I'm blocking, and blocking. Then boom, you get returning from the first function, returning from the second function, which is here. Even though it says for 1 second to be executed, it was executed after 4 seconds. That proves the point that Node.js is uniprocessed, one-threaded application. So now let's dive into manager and workers. Like I said, the manager should be treated as a POSIX thread wrapper to the workers, which should be treated as separate threads. So the manager's role is to get a job like you would get in a regular application as one for example, a request, and delegate that request to the worker. And also its job is to forward the response back to the originator. In our case, it might be the user, it might be a different application or the same application, and so on. Clean the resources of the worker. If the worker used a lot of the resources, like, I don't know, memory, and there's been it's used too much memory, and then you got to clean it. So it would clean it, the worker, by probably killing the worker, or, I don't know, helping the worker by spawning another worker to help that worker. And it's another job is to monitor the worker. For example, if you want to assign the manager to notify you by sending an email to you saying that if the worker's memory is reaching out above 1 GB RAM, you know, that kind of stuff. And the only job of the worker is to process the job and return the job or the response back to the manager. So the manager can distribute that and notify its originators. Okay? So, with less being said, we're gonna start building a manager and a worker, just for the sake of an example.
Alex, one thing, if at any point anyone has a question, please just can stop at any time and ask.
We're gonna start coding right now, so if you have questions and you didn't understand something, just ask now. Okay. So we're gonna create a new folder. I'm gonna call it example. Come on, example 10. Okay. That example 10. We're gonna create a new file, which would be our main entry point into the application. And what we're gonna do, I created some snippets. I'm gonna paste this, and I'm gonna explain what it does. So what this chunk of code would do, it would say, it would instantiate a manager, which we will create, saying, "Hey manager, please create n number of childs or n number of threads," and this chunk of code would say, "I'm gonna send a job to the manager every 500 milliseconds if the number of processes already running or the number of jobs already running is less than if the number of childs already running is less than the number of jobs I sent." Okay, someone is interfering. Okay. So, do you guys hear me? Because I hear some noises.
Yeah, I hear you. Go ahead.
Okay. So, and how do I delegate the job to the manager? I'm just calling a function called process on the manager level, where I'm passing a job to it, which is just an object with the information like block. What we're gonna try to do is block the thread, the forked thread for 5 seconds on the worker itself. And whenever the worker is done with the job, it will return a result. Now let's create a folder for the manager. Create index just to save. So now we're creating the manager. So we're gonna say the manager has access to a worker. Worker. No, not like so. And we're gonna say we're gonna use async. Please stop me and tell me if I make mistakes. And the worker, I mean the manager exports function, which gets the child number. And we're going to say function manager child. Well, we're going to use the async library. We're going to use async library for the kind of queuing mechanism by what is happening? I hear noises.
Excuse me,
Yeah.
Derek. Do you want to stop doing noises? I mean, we're trying to pick up something here.
Okay. So we're going to use async for the queuing mechanism by saying that if my worker is manager will look into the workers and would say if my worker is busy, I'm going to queue that job I just got from the process for a later time and retry at a later time to delegate that job to the worker. So that's why we're using the async library, which has another kind of like built-in library for queuing. Async. So we're creating a queue which would get the job and release. And we're going to say, so the queue will dispatch the job to the worker. So we're creating a worker inside of the queue. So the worker gets instantiated, and we just say, worker, execute the job I sent you. Whenever you're done, call this function with the error, if there was an error, or the result. We're going to go back to that later so you understand. Then the manager, as we did in here, should have a function called process. I'm going to prototype. So we have manager process would gets a job and a callback function. We have a manager process job callback. All good. Now we say that we assign the callback to the job itself, so we know how to call that callback inside here. Call it with the result. And probably that would be null, I think. Job result done. Yes. First is error, second is result. We're gonna do some console log just in case to maybe profile the thing. And we're gonna push this into the queue. We're pushing the job into the queue we created here. The second function is just a requirement for the async queue library. Oh, sorry. Console log. Time end. I'm sorry. I'm trying to profile the thing to see how long does it run by just assigning a unique ID to the job itself. So basically, this is the manager. Not much, just a queue, which actually dispatches the jobs to the workers as a queuing mechanism. Just because if you get too many requests to the manager, and for example, you got 100 requests to the manager saying process 100 jobs, but you have available only 20 jobs, you would queue those 80 jobs and try to process them at a later time. Or you could spawn as many workers as jobs you have. But that would be a stupid idea because you're just gonna halt your resources altogether. So we're gonna create an instance of the manager and return that. So that's the manager. We included it here. We pass it a number of childs, and so on. Now to the funny part. New folder. Let's create a worker. We're gonna create a new file. Be the index.js. Okay. Now, what we're gonna do also in this worker, we're gonna create another folder, and we're gonna call it execute with a new file inside. If you guys not following, just let me know, and I'll stop and go back and explain. So now we're gonna create the worker. So what we're gonna do is we're going to do module.export, and then that's gonna be a function, and the function worker, which would do this: execute require child process. So at this point, we're forking the main process. I don't know if you're familiar with Linux and all that stuff, where you can fork a process, and then the main process will become the parent of all the other processes. Some prototyping. Execute function, which gets the job, and the callback, and we're just going to assign the callback to the scope itself. We're going to assign the job to the scope itself. We might not even using. And let's do this process. Yes. So what I'm doing here is I'm going to execute worker. By execute a worker, I'm saying that I'm going to run a separate application from the main application, saying that I'm going to run the index.js, which is in the execute folder. Okay. And this is the native NodeJS API for the execute, for the forking the processes and all that stuff. So you can look into the documentation of Node.js if you want to find out more about it. So we're going to call index.js. We're not going to pass any values to it, or you could do something like, I want to pass it something like -v to the as an inline argument to the actual application. The third parameter is the options process that under. So we're saying that
I got a question.
yes.
That first array that you pass in the flags is actually is unique flags, or is flags that you're gonna be listening inside the worker, the execute of the worker.
That those flags I'm just passing -v as a verbose flag. I'm not gonna listen to that, but you could if you want to. So you can pass different arguments to the worker. Does that
Okay,
answer
so
the question?
yeah, so it's not unique flags. I mean, if you pass -b, it's not going to perform the verbose of Unix. It's just going to be
No, no,
another
no,
flag.
no, no, no. That's not going to be verbose in our case.
Okay,
It could have been if we actually use that flag in the worker itself.
got it. Thank you.
So this one says that perform everything, all the operations silently inside of the worker, and all of the output and the error output or the standard output. I think I misspelled. Yes. Type it back to the parent. So the parent would be responsible for the printing that to the console or whatever, do something with it, and so on. So the first one is for the std in. The second one is for std out. So everything. And differently. Oh. Go. And the third one is for the error. Okay. So we got those. Now.
So that means that you with the pipes are just passing whatever returns the child execute to the parent process, so you can handle it.
No, I'm just saying here that whatever I do related to std in or std out, or like if I'm canceling log, if I do cancel log inside of the worker or inside of the inside of the worker, or if I do std error inside of the worker, I want that delegated back to the manager, in our case main thread, so that main thread can take care of it, either print it out to the console or something else. So whenever, if in this case, if you do a console log inside of the worker, that console log will not appear on the terminal. It would go back to the parent, and now it's up to the manager, or in our case, the main process, to either print it out, put it in a file, send it as an output to an email, or print it to the terminal.
Okay, interesting, man. Thanks.
Worker. And we're gonna create just a quick function here. Attach process listener. That equals this, and we're gonna do this process, which references this std out on data. So here I'm listening to all the output from the worker. The data I get, it's gonna be a buffer. So we're just gonna print it out. If I don't do to string, you'll just see numbers because it's a buffer. And then this line is saying that this line is getting called will be called whenever I am done with processing the job inside of the worker. I'm gonna call the parent process by passing the message or the job back. and that's when this line of code will be called. So I'm gonna do that callback. Was it? Yeah, underscore callback and data. Process sig. What is it? Sigint. So I'm saying that whenever my worker is done with the job, just call the callback I passed to the worker class, or the worker mini library, or however you want to call it. Call the callback, which is referenced inside of the manager here. That's this. Okay, and in here, when I created that process, I probably should call this, saying apply on this scope. And process send the job. That's where I send the job to the actual worker. Now our worker, what's gonna do? I think I created a snippet of this code so we can go faster. Yes. The worker on itself, what it does, it just receives the message and blocks the worker's thread for the number of seconds passed from the job. So if we go from the beginning, what we do here, to summarize, is we're getting a manager, we're sending a job which contains a block of saying that block the thread for 5 seconds, the worker's thread, which is used here in the timeout, kind of saying that I'm going to return back after 5 seconds. And then that job gets delegated to the okay. I see. Okay, I got lost. So that job will go in the process here and will be queued. And whenever the queue, will feel that there are enough workers to process the job, it will dispatch the job to the worker by calling worker execute function, by passing the job and the callback to that function, to that worker, I'm sorry. And that's where it gets called here, gets in here. We store the callback, we store the job, and we fork the main process by passing some options, by which say that we want the output processed by the main or handled by the main process, and we attach some listeners to the forked process, where we listen to all the output data and the message whenever the worker says this process sent, which sends back the job. So if we didn't do any mistakes, this should work. Example. And nope, we did a mistake somewhere. Let's see. Worker execute. Worker, that's called in here. Okay, execute worker. Undefined is not a function. Maybe I'm not. No, I am returning that. Oh, that's wrong. That should be here. And that should be again, something else. Okay. Let me know, guys, if you see where I made a mistake. Worker, execute job. Oh, I didn't save it. Okay. Let me, before we dive into this example I wrote already, let me just open it. Desktop. So the same example. I'm sorry. There's something with my code. Let's see. It's here. Same functionality, just to show you. Same things. And all that stuff. So we're just gonna reveal in the Finder. And let's try to run it. Manager worker. My CD. Five. Yes. Basically, that's how it should work. And as a and we're going to run in parallel another application which basically simulates what we're doing with the workers, but doing that in the same thread. All of this code is available on GitHub, and we will post a link to it after the meetup if you want to download and play with it. What example is it for? So this is executing in the main thread everything. No forking, no nothing. With the same amount of jobs and the same timing applied to it. At the beginning, it's a bit slower. The workers are a bit slower, just because it needs time to, boot up those workers. But you see how fast it goes once it's that is done. So basically, the jobs get posted to the worker, and whenever it's done, it responds back to the main thread, and the thread looks, okay, my worker is free, I can send another job, and so on. And as you can see, I started this one later than the main thread, and you can see that it's going faster than this one.
Do you have an example that you want to share about, I mean, how these you can actually use it in real life, in real applications, and what was the performance that you actually get from it?
I do have that. It's proprietary code. I cannot share that code without the proper permissions and stuff. But in the repo we're gonna share, there's example, I think 3. Example 3. It's a whole blown library of the worker and manager, where you can pass the number of childs to the manager and actually pass the time for how long the worker should be alive waiting for another job. So if there are no jobs, the worker will go into the idle state and will boot up back again whenever there's a job to process, which kind of what the benefit of this is, that it's not halting your resources. It's actually, whenever the job is processed, it will say, okay, I'm done, and I'm gonna go into the idle state and release the resources to some other processes on your server. I don't know, if you do something else on your server, you would have this kind of alternation between the processes, and between the memory would be managed accordingly and properly.
How much performance do you actually get from it after you take this approach of using managers and workers?
So the main benefit is that you don't block your main process, especially if you run an HTTP server in Node.js. Then if you want to parse a big string, I don't know, you just read the string from the file system, which is asynchronously, and you get it into the main process. But now what you want to do, you want to change every second letter, which is, let's assume the file is 2 megabytes file, right? And it's a string, and you want to change every second letter to uppercase. Then that process is intensive on the main process because it's not an input-output operation, and like I said, Node knows asynchronous only with the input-output operations. That blocks your main thread. So any request from the outside world or from the client to your HTTP server will have to wait, and if it takes too long, might actually time out if you have a timeout on your requests. So that's a benefit right there.
Got it. Yeah, it's a huge benefit. So that's great.
And this is a small diagram. So basically, a user or a RabbitMQ or whatever browser makes request to the Node.js application. That request will be delegated to the manager, and the manager will delegate those requests to the workers. Whenever the worker will start processing the heavy request without blocking the main thread, and dispatch back to the manager whenever it's done. So basically, what you get back to the Node application is just a result, and very quickly you can send that result back to the browser, or put another message into RabbitMQ, or send it to another application. And that's what I have for now. Thank you. If you have any questions, please ask.
Come on, guys, don't be shy. Questions, comments?
I was gonna ask about if, I don't know if we talked, I'm sorry because I got in the middle of the talk, but I was gonna ask about if there is a tool to monitor all these workers. Like if there is a way for me to monitor all the work that has been done through my application, through those workers.
So if you want to do do so, you would have to build your own manager, or which would perform that kind of monitoring, or would have to find there are plenty of monitoring of managers already built which have that capability, so you can use those. You not necessarily need to build the entire worker manager architecture on your own. There are libraries which do that. There are also libraries which manage the clustering of your application, which is different from workers. So what they do, they actually boot up multiple applications of the same application, for example, same HTTP server, and then depending on the payload, they send requests either to one process or to another process. So they monitor the traffic. But that's clustering. It's not kind of like a manager workers thing.
That's something that can be done with PM2, right?
Yes. How do I stop sharing? That definitely can be done with PM2, and there's I don't know. That's the only one I know. PM2, actually.
Any other question, guys?
How do I stop the presentation?
All right. Well, if there's if there's no more question, well, I think it's about time, so we can just wrap up and.
Just can you give me a second? Let me post the link to the.
Yeah. Anyways, I will post on both sides in the Google community and the Gojin.
No, the comments. You can post it on the comments as well. And thank you so much, Alex. It was really nice.
Yep. Hopefully you guys liked it. Where is that? Here.
I love it. Well, okay, guys. Thank you so much for joining us again, and let's wait for the next one. I think we're gonna have something related with the Happy.js and stuff like that. So, okay, well, see you next one, and thank you, Ali, for sharing your knowledge with us and help you go through the manager, workers, and all the stuff.
No problem. Anytime.
Thanks,
Everybody.
Alex.
All right. No, thank you. See you later. Bye-bye.
I just posted the GitHub.
Ah, great. All right,
Awesome.
man.
Thanks, guys.
All right,
All
cool,
right.
man. Take it easy.
See you later. Bye bye.
As much traffic as we expect. Yeah, but I mean,